Hello and welcome to the IdeaCast interview series, episodes number 141 and 142. I'm being lazy and recording one introduction to two videos, but it's a two-parter, and my guest in these two episodes, part 1 and 2, is Dr. Tiffeny Todd. And Dr. Todd got her PhD in physics from the University of California, Irvine, and presently is a department chair and associate professor of physics at Pierce College in Washington State. And Tiffany reached out to me and wanted to share a theory that she's working on, and it was part of her PhD thesis, and it's a non-local theory of consciousness. So we have two chapters, two episodes to unpack her work. So I hope you enjoy this episode. I really had a good conversation with her, and I hope you enjoy it. Thank you. And I'd like to welcome back Dr. Tiffeny Todd to the IdeaCast interview series for a part 2 or a continuation of a conversation that, if you watched part 1, you will be joining us for this second edition or the, as I said, a continuation. So welcome. And Tiffany, glad to have you back, even though we've not really gone anywhere, but you know, the video production. So, but what we'll do in this part is maybe just do a little dialogic sorting out of what you just presented with us. And I had a curiosity when we were talking about psychokinesis and the way the brain is structured, or the way it functions in such a way that it will not give greater results without perturbation or lesioning or things like that. And so I got to thinking when you were saying that and this is where we can bring Darwin back in, or evolution, or however we want to call it, that these living systems were in niche construction, if you'll grant that, you know, so we are products of the environment, and the environment impacts us, we impact the environment, and we're in this sort of reciprocal relationship with that, and that's been part of our developmental story on and on and on. And I agree with what you were saying in the first part of the conversation, where you get these hard Dawkins type folks, that it's all selfish genes and it's all this sort of randomness, and we're automata that are, you know, just enslaved to mechanistic fortune and all that kind of thing. So, but what I would suggest, that in the inability to produce those numbers past like a 1 sigma to a 2 sigma, you know, up and up to better repeatability and better statistical weighted or averages and stuff, is that we are these products of a niche construction, and that it was not advantageous to have this faculty or this function in this environment for me to be able to tap more closely into your thinking, or to tap more into influence. And this would be an abstracted niche construction to then you know, have effect to other systems. So I wonder if that it was the constraining factor, that then we can flip this and say, in a possible scenario, that if, as the experiment was done to again with magnetics or whatever, to do the lesioning, to then afford greater statistical outcomes in predicting. I wonder if we put on our Imagineering helmet, like where we can not necessarily hack our living system, but just create maybe even theoretical models for an increased ability to interact, is maybe what I would call it. So, like, again, a random number generator, that it's more of an interactive experience than an observer-only experience. And we can make that more sophisticated. So I'll hand that to you and see what you think. But so the core of what I'm asking is, we are evolutionary systems that are products of evolutionary process, with caveats, and that this cognitive capacity that we possess, that the features of that cognitive capacity, it was not necessary to have these things as, you know, the big part of the bell curve. We're like just for basic things that we do. So I'll put that back to you and see what you think.
Yeah. Yeah, I sort of not sure about sort of the intentionality behind the design, but I can make a couple of observations. Let's start with general anesthetics. Mm-hmm. It's very interesting that general anesthetics selectively block sort of this executive function thinking. Right. Whereas other thought processes or other neurological processes can continue, breathing or, right? These other processes sort of continue. And so what I think is that when you talk about the evolutionary process, this is just a working hypothesis, is that these perturbations from the quantum vacuum of information, yes, it's an ongoing stream to some extent, but I think it's an iterative process. Mm-hmm. So maybe there's an initial communication that gives the initial voltage map, right? The initial voltage map of what the organism should develop into, what cell is going to be an eye, what cell is going to be a stomach, that sort of thing. But based on the boundary conditions and the environment, as you were saying, that interaction with the environment, there is some sort of there are automated processes, right? Where there are functions, in the biology that could become sort of automated. I like to think of it as sort of the default mode network properties versus the executive function, right? Mm-hmm. Sort of the executive function thinking comes in when you're first learning something new and you're practicing, you're creating a neurological system that then, once created, can kind of work on its own based on stimulus response, right? Stimulus from the environment triggers certain neurons to fire in a way, neurons firing together, wiring together, and then creates habitual actions of the body, right? Mm-hmm. And so I'm not saying that all of that is necessarily agential. I'm saying that those things could have developed, and then once those systems are in place, they would only be changed. You would only need new information to change those if there was some environmental factor that changed, like in the case of the flatworms, right? Where their environment changed and their head exploded, and they very quickly, new information had to come in to adapt to that change. And so this idea of vacuum orchestrated spin signaling, it's very much a perturbation of a system versus a complete executive control of every system at all points in time. Mm-hmm. This is a working hypothesis that I have. Mm-hmm. So just because I've outlined really a mechanism by which information outside of the physical parts themselves could come in and could perturb or influence to some extent the goal-directed activity of how that system forms and evolves. Mm-hmm. But even when we talk about, neurons firing the thoughts that we see, what causes a neuron to fire? What causes a change in the action potential? Mm-hmm. Sometimes it's just a reaction to a neighboring neuron firing, right? You get a stimulus and then there's an automatic reaction because, again, that pattern has been created. But then you also have spontaneous firings. And sure, those spontaneous firings could be the result of sort of just random stochastic activity. Mm-hmm. But when that sort of new information seems to come in, that doesn't necessarily, again, follow the pattern of, random mutations and natural selections over a time scale where that story would make sense.
Right, yeah.
In that case, I'm proposing another mechanism by which some additional information could come into living systems that could perturb the trajectory of its sort of self-directed, goal-oriented activity in a way that maybe can't be explained purely from the systems. And over the course of development, over an organism's development, that information, that additional information the focus of it could change, right? Because once a system is developed and sort of is on autopilot, again, I like to think of that default mode network, you don't need to perturb it anymore. There doesn't need to be additional information to it's kind of like just sort of a self-running loop of stimulus, response, stimulus, response.
Mm-hmm.
It's only when something needs to change, and we see this at least from a psychology perspective, right? Of how a lot of our reactions are, again, that default mode network, just reactionary. We don't have any sort of executive function. You can think of it like the sleepwalker and the person who's awake. You've seen studies of people sleepwalking and videos of them. Their brains are functioning. They're verbally communicating. They're input, response, but there is something very off. It's almost like the person that you know isn't quite there. It's like the lights are off. That executive function is gone, right? And so, or someone who is great at a sport or is great at playing a musical instrument, there comes this flow state that they can get into where they've used their executive function to rehearse it enough where then the brain structure is created that can almost just run on its own. So there I'm thinking, that is a purely sort of mechanistic view. I'm not suggesting that this sort of information necessarily would need to come in at that point. And this is just a very high level idea, high level philosophical idea for how this mechanism could play a role, but may not be the sole role in what we think of as thought. Because I think we have to distinguish between agential thought or thoughts, the origin seems agential, where the information seems to be new, the goal direction seems to be new, versus stimulus response.
Yeah, and I can amend what I offered a moment ago by saying what I'm curious about and the area I'm probing is expanding the enabling constraints of a cognitive system to have non-typical, non-normal, perceptive, interactive capability. So if that's a better articulation of the question, right?
Sure.
So again, it relates to the psi experiments that you were talking about, and I'm wondering, are we trapped in a cage that, as Mike Levin says, evolution dropped us off here, and it's not like we have to stay here. It's not like we're, the absolute constraints are there. It's just we have enabling constraints that we can, at this level of sentience or whatever, can explore. And that's what I was getting out of that random number generator. And so obviously we can go way out with psi and with psychokinesis and things like that. But we're taking a very cautious approach to that. And that's where I'm wondering and being curious about, this hominin here is until I peek through another curtain.
Right.
So that's where I was kind of heading with that question. It's like,
I think I understand. And I think if you want any sort of non-local, if you are suggesting that thought or consciousness has any non-local aspect to it, then I haven't seen another theory or I haven't seen another mechanism that could explain how that could physically be possible. Unless you place consciousness in the quantum vacuum, which is itself an entangled structure, from which physical detectors can then become entangled via entanglement with the quantum vacuum. Otherwise, how could my thoughts ever affect a random number generator, for example? That's a completely non-local phenomenon.
Right.
And the only thing that I think could explain it is if the thought were already in that entangled structure. It was information in the entangled structure. And the two physical detectors, one in the random number generator, one in the person's brain, are becoming entangled through that structure. So I think the point is that I'll go to like orchestrated orchestrated objective reduction is another quantum based theory of consciousness proposed by Penrose and Hameroff. In that theory, it definitely takes sort of more of the Copenhagen view, where you have physical structures in the brain that are in a quantum superposition, right? You have a physical structure that becomes a wave, and then the wave physically collapses. And Penrose proposes that collapse happens under gravity, that it's an unstable superposition, and that it literally collapses. And there's this idea that microtubules are, those quantum objects. So think of them as like qubits, like a quantum computer type model, where consciousness is sort of like, it's not really clearly defined what consciousness is. It's sort of like this life force that kind of comes through when the collapse of the wave function happens. It's not quite clear what that necessarily means, but I think the logic here is because microtubules are in all organs of the body, and how is the mind different in its thinking than, say, a microtubule, or than a liver? My mind thinks, brain thinks different from a liver. How is it different? This idea is that, the consciousness that comes through when the wave function collapses is this primordial consciousness, like almost like a life force, maybe. I don't know.
Yeah. Elon Vital or something.
But that the actual thinking is still a quantum calculation through these quantum superpositions that are collapsing in the brain, these kind of qubits in the brain. And so I'm taking the opposite approach. I'm saying that the information in the quantum vacuum is actually a larger set of information than what we're seeing reflected in the signaling to quantum objects, which are these radical pairs. And so in that sense, you then open the door to the possibility of how minds could be entangled, if you will, or how a mind matter interaction could occur. If the mind itself is in an entangled structure, then if you have two quantum detectors, again, the radical pair in the brain, the random number generator, the virtual photons there, then that information of the mind, it can signal to the brain. But when part of the brain is disrupted, and it's the part of the brain that tends to create our sense of self and sense of boundary of what is us versus what is the exterior environment. There's something about when you break that boundary of what is me and what is the boundary, meaning it's almost like the signal is directed to what is my defined boundary. And then when you break that and another part of the brain is focused on another object, then you can have an effect, or you can have the signal maybe bifurcated to those different physical systems. The only way I could explain that is through what we now understand of the quantum vacuum, and that it's this infinitely entangled structure that stores information that can be accessed through quantum detectors.
Right.
And I need to pause 1 second. I have a battery that I'm going to have to, so we could splice, I think.
I'll just hit pause. That Zoom affords us that capacity. So I'll hit pause, and then we'll just come back on when you're ready. Okay.
Great. I'm just going to plug in a cord so I don't lose you.
Okay. Okay, so do you want another question, or did you have a thought for continuance on what you were talking about?
No, I'm
okay.
Yeah.
All right. And
if that answered at all, I think what you were getting at is this capacity to enhance the mind's ability to entangle with information that we think of as being specific to other systems, biological or physical.
Yeah, and oh, sorry, go ahead.
No, I think the first step to that is having a physical mechanism by which such a thing is even possible, which I think the mechanism I'm proposing is, I think, the first that really draws a clear mechanism by which such a thing could be possible.
Mm-hmm.
I think, remember I said in that field of psi, there's sort of three obstacles: the effect size, the reproducibility, and then a sort of physics-based mechanism that could explain how it could work. And so, this, I think, is an important first step, is even just proposing a mechanism. I think at least maybe opens the field up to possible consideration. Whereas before, if there's really no physical possible means by which it could occur, then it's sort of no point in really exploring. So I think it definitely opens the question. And I think it hopefully there'll be sort of more work. I think, again, the breakthrough of recognizing that there is something to the systems, the cerebral systems, the neural networks that are developed that can block this capacity, and understanding that, it's not, and how do you create this? How do you break that down? How do you, create a situation where the model breaks, and then you can really understand the model more? I think that's classical, scientific experimentation. We break something to understand it. So.
Yeah. And let's just say if that happens to be subtractive, where we're taking something apart to zero in on something, where again we disable that part of the brain that sees self-other boundary or self-environment boundary. I would also think of an additive approach, and we can bring our friend Michael Levin back in here with his morphocompiler, or his ideas about an kind of unlimited morphology or beyond what we have morphology, and that so part of the drive behind my question earlier was we have this cortical capacity that affords us self-reflection, metacognition, the light cone that Mike talks about, where we, unlike probably the majority of species of living systems on this planet, that we have the capacity to reflect on memory and reflect on the past, and then also do predictive processing and look to the future to a degree that I don't think any other creature has. So to say that is that it was just a simple matter of the expansion of cortical capacity or cortical folding in the front end of our brains. And if something like that can happen and grant us that, and if we wanted to be cynical and skeptical, if it were possible for instinctive animals like we were perhaps 2-3 million years ago, before we did all that they would say it's impossible to have self-reflective, metacognitive, agential, so the argument that I say that for future sake. So like we're sitting here poo-pooing certain things that could be a little woo-woo or a little out there, but I want to firewall that, of course, but it's just like, well, if Mike gets his morphocompiler online, or some student of Mike, and we do things with our brains that allow us to interact with, shall we say, the infinite possible information field of the quantum vacuum and its entangled structure, what's going to happen from there? I wouldn't speculate, but it's just going to be interesting to know where we can go.
Yeah, and I think that there's an important distinction that you're raising between enhancing mental capacity, the brain's sensory capacity, the body's sensory capacity for information, versus psi or parapsychological perception. I think it's important to make the distinction, and because yes, I think obviously, a simple example is, a dog can hear more frequencies than my ear can hear, or a bird. We think if the radical pair mechanism is how birds are sensing the magnetic field, it's a visual sense. And so the birds are able to then perceive in, ranges, or other animals we know are able to perceive frequencies of light that we're not able to perceive. And so you can think of, well, could we adapt the human eye to be able to receive in a broader spectrum of light? And that enhanced perception is purely explained by current models of physics. It's just expanding our perception of the physical world. But that perception is still limited by classical physics, meaning that I can't perceive something by any means other than light signaling, right? And light signals travel at the speed of light.
Right.
So, for example, like that interaction with the number generator and someone just thinking about making tunneling events happen more quickly, there's no physical mechanism or established physical mechanism other than the one that I'm proposing that I know of that could like physically explain how that could occur. So I think there's definitely a difference between, enhancing our bodies, our minds to perceive more. I think there's been talk of, how could we, even perceive the weather or, have more of a sense of get more information from our physical environment. But that information, again, is still coming to us through light signals, photons, in terms of the eyes, or through in terms of all of our other physical senses. You're talking about subatomic particle interactions.
Mm-hmm, mm-hmm.
It's just explaining the range and the sensitivity of those.
Yeah. But that sense data onboarding is still being handled and processed by something that's core to your VOS system that I think, if I'm reading this right. And so the interpretive phenomena that occurs once sense data is onboarded is that, I believe, that connection to now limited, but perhaps broader capacity for processing, if you will, or whatever metaphor you want to use.
I would argue, I don't know if you would need VOS to explain the body's ability. I think you could use sort of a classical models that we already have to explain sensory processing. Mm-hmm. Because you can really use a computer model, right? Yeah. Where you, the brain is developing, you have sensory stimulus, which then shapes sort of the networking organization of neurons that then, and that structuring process would just be different with expanded sensory input, right? And we see, there are experiments with cerebral organoids now where they're actually looking at brain development in artificial brains and then starting to give it stimulus like light stimulus and seeing how the neural connections develop and change the more stimulus it has. So I just in fairness, I think you could explain that with, I think the classical models that we have in terms of stimulus and response.
Mm-hmm. Yes, but again, I'm going to probe this a little further because I want to integrate it to what you've so carefully explained, and that, let's just say we are bound to that informational capacity of the vacuum as aggregated cellular systems that have complexified through, again, a process of millions, billions of years, whatever, wherein we can see a single cell, a xenobot, an animalcule of some kind, having agential capacity, interacting agentially, it's decision making, it's volitional in a sense, and so I could be. You'll have to correct me. You'll have to steer me back on board, but I'm relating that to that potential in the quantum vacuum that at the very most discrete level of cognition or consciousness, if we will, and I'm not going panpsychist here. I'm just saying that our current aggregated our system that we are, if it continues to grow and evolve, which I said this to somebody the other day in another conversation. We're at evolution 2.0 right now. We're not bound by Darwin anymore. We have this new set of rules and set of things, and Michael is spearheading this, in some of the talks that he delivers in his monologues and so forth. So anyway, I just want to connect everything. Yes, sense data onboarding, information processing, like information theorists, what number I love to throw out there is that we get 10 million bits per second of information, and we only have access to about 40 to 120 of those bits. Okay, and like you said, we can stay well within the bounds of relativistic physics to do a lot of everything, but I want to cross that threshold back down into where I think the spirit of this conversation is, in that, and your theory of consciousness, if I can call it that, is what it's indicating is that this system is classical. This system is deeply embedded and engaged and enacted with its environment and the sense data collection and processing. But like I said, when we're at that threshold of the non-classical system down into, again, what might be called quantum, but definitely of the quantum vacuum for consciousness or cognitive processing at its most discrete primitive to this complexified structure. So does that make sense? Because like I'm trying to build a bridge between one classical system at our macro scale and what I think you're proposing with consciousness as it is related to the quantum vacuum expressing itself or distributing itself or whatever.
Yeah, and I think my, scientific caution wants to really confine, I think, the conclusion that Voss is drawing, particularly as it relates to other sort of experimental evidence that's sort of out there. I would say that what I'm proposing is a way that agential information, again, translate into the voltage map that we see as thought. In cases where it's not quite clear necessarily where the information of the voltage map comes from. And there are other theories of where it comes from. There are theories of that it's simply a product of evolution, if you will, like a product of sort of boundary conditions, natural boundary conditions, sort of, again, we talked about random mutations that just sort of follow laws of physics that it looks like a pattern, but it just happens to be the pattern that we see because of the environment in which that pattern was shaped, right? Sort of like, why do we see bell curves? It's because it's just, natural distributions based on certain boundary conditions, that the shape there's not necessarily an intelligent design behind the shape, but it's just, again, a product of physics. It's just a pattern that happens to emerge based on certain boundary conditions. I'm just proposing an alternative that, perhaps, it's not just a pattern that happens to occur, but there's some sort of agential information that comes in that's greater than the sum of its parts. I think also, when it comes to this idea of cognitive light cones, I think it's really interesting. I think, again, I want to distinguish my view from, I think, what is the standard scientific view that prevails, that I'm proposing an alternative possibility to. Again, I think the standard view is that, again, these physical parts, that the voltage map, the patterns, the thought, is emergent from the complexity of those networks. And therefore, say, an artificial intelligence, if you have the same level of network complexity, that would be just as agential. It would demonstrate the same type of agency as a biological system, that there's really no distinction between molecules that are making up a biological agent versus molecules that are making up an artificial agent that has programming and directives. And I think I'm proposing what would distinguish, by definition, a biological intelligence from an artificial intelligence, because this streaming of information to these radical pairs, again, the radical pairs are created through the process of metabolism. This is something only biological systems do. And so when the metabolism stops, when that oxidation stops, then these radical pairs are no longer created. So those antennas go away. And then what I'm proposing is that these antennas, right, think of them as a coin flip, heads, tails, head, tails, head, tails. Mm-hmm. I'm proposing that there is an agent, an intelligence that comes in and perturbs it to be a little bit more heads, changing the voltage patterns we see. A slight perturbation. I'm saying that some other information is coming in through this quantum vacuum mechanism.
Okay.
Which is different, again, from the standard view that biological systems and artificial systems will become in our agents, conscious agents, just based on the fact that they are exhibiting goal-directed activity. I'm saying that I'm calling the definition of agency is one that is not calculable. Whereas I would argue that even artificial intelligence, just because it's a black box and you don't know how it came to its conclusions, you can find out. It would be very time consuming to sort of backtrack and find out why did the AI come to the conclusions that it came to. But you can, it's always calculable. You can always backtrack and calculate where based on some prime directive, and even though the AI may come up with novel ways to get to a certain end, you can always calculate based on that prime directive, right? So I'm proposing that true agency is something that is not calculable, yet is not random, but constitutes a perturbation of a deterministic path or even a probabilistically calculable path. I'm proposing that true agency is some deviation away from that in a way that represents a goal-oriented information. That's not just a random deviation, but a goal-oriented deviation. Perturbing the radical pair to be more, spin parallels versus anti-spin parallels, to function in firing these neurons, but not those neurons, to create a particular neural pathway that represents a new memory or a new way of the neurons firing together. Right? New sort of brain structure, if you will. And so I think that really is an important distinction. I think also if I'm saying that all of the mentation, all of the cognition, at least the executive cognition, again, I'm not talking about that sort of stimulus response, that's on sort of autopilot, but that new cognition that is coming in, I'm proposing that's all happening in this information field of the quantum vacuum, that entangled information field. And I think that's something that's very different. I think there are some philosophies that, mentation, I forget the name of the philosophy where, the core of reality is mentation. But again, like the Penrose-Hameroff model of Orco-R, it's sort of like a primordial consciousness, but that actual the actual computation of thinking is still something going on with the neurons or something going on with physical mechanisms like microtubules in the brain, where it's the physical, almost like it's a network, and that the processing of thinking is happening at the level of the physical. I'm proposing something radically different. I'm proposing that the processing, the actual thinking is happening in the quantum vacuum, and a subset of that information is being signaled to these quantum antennae in the brain, in different areas, as needed to perturb the system and alter its goals and its trajectories in relation to its environment. So I don't know of another I would say, scientific theory or mechanism, I would say, that proposes a mechanism by which that occurs. Because another consequence then of this, if we want to get really woo-woo, right? Another consequence then of this is if the radical pairs stop receiving the signal, that doesn't mean the signal has stopped. So think of the brain as a television, and just because the television
The
cord
transmitter.
is pulled out or it dies, that doesn't mean that the broadcast isn't still going, which then, I mean, if, like I state, if you want to get really woo-woo, this then allows for the possibility of the survival of a particular stream of consciousness, even after the physical is no longer there.
Okay.
And it also allows then for the possibility of a person to sort of hack the cell phone signal of someone else or pick up information from a stream of consciousness that is no longer necessarily streaming to a physical body. So I would say, Vox, it really does allow for the possibility of these other parapsychological phenomenon that we have, some weak evidence over the century of, but perhaps now that a physical mechanism is being proposed for how it could take place, perhaps it might inspire better ways of testing if those phenomena are real, or if we could measure them in a more substantive way. And I think it's an interesting question. I know it's a little bit taboo to talk about in serious scientific circles, right? This idea of parapsychology, it really is a very fringe idea. But if there's nothing to it, well, then it really doesn't change the trajectory of science and consciousness research, right? We're on the right track. If there's nothing to it, there's nothing to it. But if there is something to it, that would be very paradigm shifting for our approach to studying consciousness. I'd argue it's almost like the same as the shift from the geocentric model to the heliocentric model, right? If we're thinking that physicality creates consciousness versus the idea that consciousness moves physicality, that's a real paradigm shift. It's turning things on its head. And I think it would have implications for how we pursue our science. And the last thing I'll say about that is I really do like Michael Levin's idea of this cognitive light cone, where there are some agents that have a broader ability or lesser ability to create goals within a certain space. Physical space or space-like goals and time-like goals, right? Over the ability to imagine over a certain time scale and the ability to sort of create goals imagine a certain space. And this idea that perhaps he postulates that just as there are agents that we analyze, animal agents, plant agents, that have smaller cognitive light cones than us, we can envision the idea of agents that have bigger cognitive light cones than we can even conceive of. And so that's where I get to this idea of the cognitive information in the quantum vacuum being greater than what is necessarily streamed to a particular conscious agent.
Yeah.
Because there are studies that have been done, I'm going to go really woo-woo right now, on mediums, for example. And mediums and their ability to communicate with streams of consciousness that are not streaming to a physical entity, a physical brain anymore. And it seems that these streams of consciousness actually have information. They actually have a perspective of a cognitive light cone that seems greater than us. It almost seems magical. They're able to see trajectories of things that are kind of coming. They're able to recount things that are happening at distances that we cannot see through light signaling. And it's like, well, how can you have information beyond, it seems like they have broader cognitive light cones than than we do.
Mm-hmm. Mm-hmm.
And it could be this idea of, dimensionality, from some sort of higher perspective, you're able to have a different viewpoint. You're able to see trajectories that from the viewpoint, a lower viewpoint that you're not able to see, for example.
Yeah. Yeah.
So it opens up that question of those possibilities. And so it's, again, right now, my focus is just focusing on the mechanism and the physical mechanism. What is the empirical evidence for this particular mechanism? And making sure that, the thresholds that would be necessary, actually, the mechanism could actually function in the way that I'm describing. So I'm in the process of writing the paper now to sort of flesh all of that out. I think my PhD research was perfect for this because it was based, the physics, the quantum mechanics of the radical pair mechanism, but I had to link that to sort of behavioral studies that we see in birds, where birds are able to navigate in certain wavelengths of light and not others. So then that focused us on, what could the radical pair, what could the light sensor be that operates within that photospectrum? And so you're sort of taking these behavioral studies and trickling that down to how this actual quantum chemical mechanism could work. And so sort of the same thing here. Again, this idea, it sort of, again, spans the biology, the chemistry, and the physics, and how all of that, those scales mesh together. And at those boundary points, is the threshold sort of for the virtual particle fluctuations, what is the threshold that would be needed to see the effects that we see in like the psychokinesis experiment? How much perturbation would you need to have to actually get a signal? And so those are the types of things that I did with the radical pair mechanism in birds. So that's sort of what I'm working on and focused on now with Voss. And I think, once there's a mechanism, it then opens as if more evidence comes about to support this particular mechanism. It at least allows sort of other avenues of experimentation, right? Because you're not going to design an experiment for a model you can't even conceive of. And so I think bringing this other mechanism in is, could provide interesting avenues for experimentation, both in just regular standard consciousness research, but also in that sort of parapsychological realm. And, we'll see what happens.
Yeah. And, to future think, you're going to do your work and others will pick up the work and do the Toddian, perspective or the Toddian principle or whatever it manifests to be. And so this is not all lumped on your shoulders. I think once it's in distribution, no. right. Cause I was saying to you earlier before we this
is really just the blueprint of the mechanism.
Yeah.
But again, like I said, it spans multiple different fields. You're talking the results of relativistic quantum information. There are experts that know way more about that than I do. It links into, the quantum spin chemistry of the radical pairs, linking into the biochemistry, within the cell, and, the control, how radical pairs control ion channels, in what cases, to what extent. I haven't specified what the radical pair is or where it would be located. Again, there's tons more work, but the idea is at least to lay out the framework and what the empirical evidence that kind of supports all of the aspects of this particular framework. And I think why it's important is it maybe opens up the possibility that our ironclad assumptions that consciousness is emergent from networking, it perhaps offers another possibility that I don't think has a clear mechanism has been presented before. People have been saying for ages, like dualism and, this idea that there's something else besides the physical. But the question has always been, well, what else? And I consider myself very much a physicalist. Even if there is something else, meaning some other information, there still has to be a physical mechanism by which it interacts with the physical brain, what we see in the brain, what it correlates with as thought. It's those voltage changes. That's what we see. We know that correlates to thought. So there has to be a physical mechanism by which something else could bring free will agency in.
Mm-hmm.
So, yeah.
Well, I have a couple responses, and then I have maybe something to ask you as a curious person asking a physicist. So, but let me offer a couple of responses. As I said, I think you're not alone in this undertaking, and if you when you're published, that it'll be interesting to see not only the feedback and the peer review and all of this, but people who pick up the work and again carry some of the load and like you said, do some of the decoding, do some of the formalizing and things in different domains. That's going to be fascinating. Now, where do I start? So to deal with the idea that we could go off the rails and go into woo-woo land and all that, I would, for myself, and you just said you're a physicalist, I would say that we can keep all of this in the natural context frame. We do not have, I reject supernatural blah, blah, blah for everything, I'll die on that hill. But the natural frame is a deep and profound frame. And who are we as hubristic hominins? Ancestors our ancestors are monkeys. So we have to slow our roll a little bit and know that in the natural frame, there is potentia that we have not unearthed or whatever metaphor, so we can be epistemically prudent, but we also have to have the imaginal turned on to always have that kind of inquisitive lensing, the inquiry, the curiosity that science is supposed to do. So that's my solution to that. We can throw things at the wall, see what happens, and if things are silly, then they go away, and we can continue to pursue inquiry in an epistemically humble way, or I should say rigorous way that affords us that capacity to discern. And then so the other thing I would say is in your RPM, your radical pair mechanism, that I would infer from what you've said, and I'm silly, I don't know if I could come up with a good inference, but I would infer that it seems like RPM would be a necessary component to any living biological metabolizing system. Maybe that's super obvious to you, but that's just one of my nice takeaways from that, because this is the seed of consciousness as a system relates to the vacuum, if that's the right way to say it. So those are a couple of things that I took away from this part two. And if you want to respond to any of that, or I've got this other thing that I just want to ask you a question. So if you want to respond, that's cool. And then I'll ask you a question and then we'll wrap it up, because I think we've been, it's hard to believe the time goes by so fast, and I don't want the audience to have too much to deal with.
Yeah. And I think there's some preliminary research supporting the idea that the radical pair mechanism might be the mechanism by which consciousness either emerges or is signaled, as I'm suggesting, to the brain. Now, this is theoretical modeling, but we learned that general anesthetics, because if we're going to get to the heart of what consciousness is, we really need to understand how general anesthetics work. We want to understand the mechanism of consciousness. We need to understand the mechanism by which general anesthetic work. And the fact that we don't understand the mechanism by which general anesthetics works is a clue that we haven't quite nailed down what consciousness is, how it emerges from physical networking, or if it is a signal being received by radical pairs, as I'm proposing.
Mm-hmm.
One possible clue is that general anesthetics are isotope dependent, right? Mm-hmm. So you have xenon, general anesthetic. Inside the nucleus, you have a certain number of neutrons. If you add or subtract neutrons, obviously you don't change the charge of the protons and electrons, that charge balance. But what you do is you change the weight, right? You change the nuclear environment. Now, what's important about that is the more neutron, the number of the nucleus itself has a spin, has its own spin. And that spin is like, you can think of it as a magnetic field, an internal magnetic field. And so radical pairs, we know this in the both experimentally and theoretically, but the radical pairs are going to be sensitive to any external magnetic field. They possess that magnetic field. And if one radical pair is sensitive to the external magnetic field as well as the internal nuclear spin. So remember I said there were two sort of atoms in two different molecules, right? And one donates an electron. Those nuclear spin environments are going to, they could be the same or they could be different. Imagine the nuclear spin environments are the same. That means each radical pair's electron spin is processing about the nuclear spin, right? Nuclear spin environment that it has. If one also has, or let's say you have an external magnetic field and you want to test the sensitivity of this radical pair mechanism to external magnetic field orientation. Let's say that one radical pair has a nuclear spin environment that is different from the other. And so the precessions that you're going to get are, it's going to cause this, it's going to cause the orientation of these spins or the state to change. Okay, you've got like the singlet state and this triplet state. It's going to cause that changing depending on that spin environment, that nuclear spin environment. So the radical pairs are sensitive to the nuclear spin environment. So if you add in a general anesthetic that has a particular, it could easily perturb the nuclear spin environment that those radical pairs are operating in. And so if you change the nuclear spin of the anesthetic that you're using, it would make sense that that would then alter the effect of the radical pairs and how they're processing around that nuclear spin environment. So what we have here is we have a correlation. We know that radical pairs, their function is dependent on their nuclear spin environment. And we have that general anesthetics work better or more or less effective depending on the nuclear spin environment that anesthetic has.
Okay.
And there was a research paper that modeled this and was able to predict or model the effectiveness of a general anesthetic depending on the nuclear spin environment. It was able to reproduce the experimental results that we see of how anesthetics are dependent on their nuclear spin, the nucleus, how that isotope dependence could be explained if consciousness is being orchestrated by a radical pair mechanism and the general anesthetic is disrupting that radical pair mechanism. So that's one sort of piece of evidence or support for this idea that radical pairs are somehow orchestrating consciousness. And in Voss, I'm saying that, yes, that the radical pairs, that information of consciousness is being signaled to those radical pairs, and that general anesthetics disrupt their functioning. Allowing for other mental processes, those sort of automatic mental processes, to continue. But general anesthetics are unique in that they really do select for that executive functioning thought, right? It doesn't shut off all neurological activity. You're still breathing, you're still, all of those reflexes are still there under general anesthesia, right? But it can target the actual experience of consciousness, that sort of going to sleep, lights out.
Right.
And that's what Voss is proposing, that executive function thoughts are again being signaled to these specific radical pair arrangements to create that conscious experience. Really what I'm saying is, this is the last analogy I'll give and last sort of experiment I'll point to is, what I'm saying is rather radical. I'm saying that you think you're in a body, but really you're in this quantum vacuum. Now, the quantum vacuum is everywhere, but that it's your focus on a particular physical mechanism, this radical pair mechanism, this brain mechanism. It's this focusing on only sensory information that is being filtered through this body. That is what you're focusing on for your experience. And we talked about the possibility of entanglements where you could access other information. But yes, from an evolutionary perspective, we want to focus on only the sensory information that's coming in through this physical avatar. As per my theory, is the idea that it's an avatar. And that may seem strange, well, but I think I'm this body, right? I'm having a very clear experience that I'm this body. But I don't know if you've ever seen the fake rubber hand experiment, where, you can very easily, if you focus on a fake rubber hand being stimulated, as your physical hand is being stimulated, you're getting the sensory information into your brain. You very easily begin to identify with this fake physical object as who you are, to the point where if someone tries to stab it with a knife, you'll jump, right? You'll have that visceral reaction. And so I think that it's almost like a hypnosis. It's like we're so focused on the sensory input from this physical body that's how we're identifying as sort of what we are, even though I'm saying that the mind, the consciousness that we are, is not quite emergent from this physical body, but is sort of being streamed to this physical body. And I think the psychokinesis experiment, what it did is it's like the rubber hand experiment where you break the illusion momentarily, where you disable that boundary of self, and you mess with that illusion of what we think is the boundary of self, and you start getting some information about another quantum system, where you then start affecting that other quantum system, and that creates that sort of entanglement in which you can then have an effect on that other system. And so that's what I'm proposing. If it seems weird, you're proposing that you're this information stream in some quantum vacuum, but it feels like you're a body. I think that could be just a question of focus, focus on sensory input, and the mechanism of the body is designed that way. Yeah.
And going back to something I said earlier, evolution, if you will, dropped us off where we are. And we intuit that we are, like you said, a structural system, a system of tensegrity that stays together in continuity, and there's a continuity of selfing and all these things. Yeah, but and we see in pathology that can depersonalization, psychosis, all these different things can demonstrate, or even psychedelic use can demonstrate the dissolution of that stream of selfing, and that it's quite tentative and contingent. So yeah, there's evidence to support, I think, fairly that we have to hold that we are this ontic thing, and it has a steadfastness or a steadiness to itself. So, but yeah, I agree. I think a lot of things are up for debate as far as the reifiability of a solid self and all that kind of thing. So, but the two little nerdy things that I wanted to check in with you on kind of tie into this a little bit. There's two little things I love from physics, from watching interviews and conversations. One is Sylvester James Gates. He used to be at the University of Maryland. He's a physics professor. The guy's crackerjack, really smart. And he, in the 70s, his PhD thesis was on supersymmetry or superstring. I can't remember. I think it was supersymmetry. And in the early 90s, they were formalizing and doing calculations for this idea about supersymmetry. And he said that in the maths, in the equations, they found the block linear it's block linear error self-correcting code, I think, which is what is used in internet communications. It's what's keeping the cloud in congruity, and when we send a JPEG image across the internet, it reassembles with minimal error. And so they're finding that in supersymmetry. So that to me is interesting, that they're in nature, that continuity is self-correcting, and it's not just Sylvester James Gates. I've heard it come up in other conversations in physics before. And then the other thing that I can maybe correlate is the Hawking-Susskind et al. Big kerfluffle back, I think it was in the 90s, where they were talking about the resolution of Hawking radiation at the brain of a singularity of a black hole, and also maybe the brain of the singularity of the universe. But the focus on the argumentation was that brain singularity at the black hole event horizon. And so Hawking was struggling with, are you information or are you physicality when you pass through the singularity? And he thinks you just dissolve into information. But Susskind was basically saying, well, no, it's concomitant that, until you just, the black hole destroys you, there is that moment where you are both informational and a physical system, like we take ourselves for granted to be. So I thought that was interesting, because that's what led Susskind to come into this whole holographic thing. And he proposed again at the singularity of this universe, the brain, if you will, that it's informational. It's a 2D informational disk or whatever, that is all of this, right? So that reminds me of the quantum vacuum when he's talking about this and elaborating on it, that it is information coalescing as probably energy coalescing into discrete packets of physicality that become what we are and what the world is and the universe and all that. So those are my geeky things that I just love to think about. And it ties, I think, in a way, or at least helps me reconcile a little bit about the quantum vacuum and this sort of unlimited fount of information. And we could even say, intelligibility through that these systems can process in that information. So anyway, I don't know if you want to respond to that. It's just geeky little things that I've picked up over the years.
In relativistic quantum information, they're definitely exploring all of this phenomenon.
Okay.
As to black hole event horizons, as it relates to, when you're accelerating, you create particles, sort of virtual particles, whereas when you're not in an accelerating frame, then you don't. So,
okay.
They're exploring it from a experimental perspective and a fundamental perspective that really is getting at the heart of this intersectionality between relativity and quantum physics, and really looking at getting clues as to where a reconciliation might occur. And so I think, the findings that they've already discovered, that, this, Valentini discovering that, the quantum vacuum is this infinitely entangled structure, that you can harvest that entanglement to entangle space-like separated objects. You can even harvest it to entangle time-like separated objects, meaning that I can have an entanglement between myself now and myself in the future. So this sort of gets at, again, going a little bit woo-woo here, but with the remote viewing experiments, which I've had personal experience with as well. I'm sort of like and there are, I'm forgetting the name of the researcher as well. There were a number of parapsychology experiments on precognition recently. I can find the reference and get it to you, but it was a series of experiments that seemed to show over very short time scales some precognitive capability, meaning that I can get information on what I'm going to perceive a few steps in the future. Okay. And again, significant effect sizes. Again, in parapsychology, most of these experiments are behavioral experiments. So they're done at the level by psychologists at the level of psychology. And we know there's been a lot of controversy over psychology experiments in terms of what do we consider statistically significant. I think this series of experiments on precognition definitely brought that to a head, where I think the conclusion was, okay, if we're seeing precognition, there must be something wrong with what we're calling statistical significance, so we need to raise the bar. And I think that affects psychology experiments all around. I think we can have a debate about whether that's the right reaction to have when you have results that don't fit the physical model or that seem impossible with the physical model that you have at the time. Do you then say, well, there must be something wrong with how we're measuring statistical significance? Or do you actually take that evidence and say, this is something to perhaps consider? It needs to be accepted into the cadre, of knowledge, and it needs to be considered. But I think it's interesting in relativistic quantum information that now we are seeing that we have a physical mechanism by which two objects that are time-like separated could obtain information about one another through entanglement harvesting, meaning information across time and information across space. That in principle creates the possibility of, again, getting information through non-light signaling, right? Or this sort of precognitive phenomenon. But what's missing, of course, is the link with how could the brain be a quantum detector to entangle with the vacuum? And that's what I'm proposing through the radical pair mechanism as a possibility to consider.
Yes, absolutely. And I've been honored to host you to explore these ideas. And I would like to have you back at some point, maybe when you've published. And then again, if, and we talked about this off record, that I will try to get some names to you of folks that could be supportive and helpful persons in the post-publication and what to do with, with the implications of all this. So I'll do that little bit to see what comes of that. But yeah, if you want, let's have you back at some point. And maybe I can find a guest to have you in dialogue, and I'll be the Vanna White. I'll just be the little host on the side, and you can have a person that you can talk with if I find somebody I think would be a good fit to explore these ideas. So if you're game for that, we'll do that for sure. So, but thank you for today. Thank you for the two conversations. I appreciate it. I know my audience will have absorbed it and have good takeaways, good things to think about, consider. So much appreciation to you for that, Tiffany. I appreciate you being here.
Yeah. Thank
Yeah.
you.
All right. So to the YouTube audience, Tiffany, I'll say goodbye to you after we're done with the record. But Tiffany, to the audience, I will say goodbye to you all, and we'll see you in the next episode. And thank you so much for being here.